Mr. Lubasi, a 60-year medical student. Welcome to part 2, solving forces acting on an inclined plane. And today's problem is it reads, a block takes twice as long to slide down an inclined plane. That makes an angle of 35 degrees with the horizontal as it does to fall freely through the same vertical distance h. What is the coefficient of kinetic friction? Okay, so to solve this problem, of course, we need to collect our data. That is the first thing, what we have. Okay, so the inclined plane is shown here. So we have a block, okay? We have a block which is sliding down the inclined plane. We have the same block which is falling freely, okay, through the same vertical distance. So the distance this block which is sliding down takes to move from this point to the lowest point is the same as the distance it covers when it just drops, when it falls freely from this height. The height, the distance is just the same. But now they are saying that the question says it takes twice the time. Okay, it takes twice the time to slide down. To slide down an inclined plane as it does, like twice to slide down the inclined plane as it does when it just falls freely. So what it means that if it takes t seconds to fall from this height to the lowest point, it will take 2 times to slide down the inclined plane. This is what it means. Okay, now let's collect our data. So having talked about this, let's collect our data. Okay, so we have our data. What we have? We have the angle, okay, which is 35. Okay, the height we don't know, so we also don't know the distance it takes for this block to slide down from this point to the lowest point. Okay, we don't know the distance. Okay, we don't know the acceleration. Okay, we don't know the acceleration of the block along the x-axis. Okay, what else are we supposed to do? We are supposed to resolve the forces, okay, acting on the inclined plane. So how do we resolve the forces acting on the inclined plane? We know that we have the weight, which is mg. Okay, we have the normal force. Okay, we have the x component of the weight, which is mg cos theta. You know, we are applying SOHCAHTOA, where we know that the angle here is the same as the angle here. So this angle here is 35 as well. Okay, we know that if this angle is 35, this we have a right angle triangle here. This is the adjacent. Okay, this is the adjacent, and this is the hypotenuse. So we use cos. Okay. Then here mg sine theta. This is the x component of the weight. Okay. So since this block is sliding down, we have the friction force, which is acting in the opposite direction. Okay. So now we need to know the summation of forces in the x-axis and the summation of forces in the y-axis. So what we need to find? Summation of forces in the x-axis and the summation of forces in the y-axis. So, but in this case, we know that okay, we need to know the summation of forces in the x-axis. All right, then now our solution. Okay, so our solution. Let's find the height. So how do we find the height? This height here. Okay, so we're going to use the kinematic equation. So we're going to say height is equal to initial velocity times time plus 1 over 2 gravity time squared. Okay, we know that the initial velocity, this one, is 0, Okay, so h is equal to 1 over 2 gt squared. Okay, so this is our height. All right, but we know that since the question says it takes twice as long to slide down, so we're interested in the time. So how do we calculate the time? So to calculate the time, we're going to multiply this by 2 over g, even this side 2 over g. So what we have, this, and this will cancel. So we'll have t squared, which will be equal to 2h over g. Okay, we square. Therefore, the time will be equal to the square root of 2h over g. Okay, so meaning for the block to fall freely through this vertical height, it takes a square root of 2h over g seconds. Now the question, it says for this block to slide, it takes 2 times this, meaning for it to slide. So this is for free fall, then sliding, okay, will be equal to t will be equal to 2 times. Okay, it will be equal to 2 times this time. Okay, it's going to be equal to this for sliding. All right, now let's find our x. Okay, so you know that this would be, it's a right angle triangle. So to find the x, we know that we have the opposite and the hypotenuse, so we use sine. Therefore, we know that sine theta will be equal to opposite over hypotenuse. So what we want to find is the hypotenuse, which will be the distance. So the hypotenuse, sine theta, okay, we cross multiply here, will be equal to the opposite. Okay, okay, so we're interested in the hypotenuse, which is the x. So that we're going to divide by sine theta this side, sine theta this side. Okay, so the hypotenuse is equal to the opposite sine theta. So now what is the hypotenuse? It's x. The opposite, it is the height over sine theta. Okay, so we have our distance. So it takes h over sine theta meters for the block to move from this point to the lowest point. Okay, so now having found, let's find the acceleration. How do we find the acceleration? So to calculate the acceleration, we say acceleration, okay, we know that force is equal to mass times acceleration. So now what is the force? Okay, so to calculate this, we're interested in the acceleration. We're going to make acceleration the subject of the formula. Okay, so therefore acceleration is equal to force over mass. Okay, so what is the force? So the force, this is the summation of forces, the resultant in the x-axis. That is the force. Okay, so now how do we find this force? Okay, so we have this force here, the mg sine theta, which is the component of the weight, which is pushing the box downward, okay, or making it to slide down, and we have an opposing force, which is the friction. So we know that, okay, I'll show it just here. So the summation of forces in the x-axis will be equal to max. Okay, we know this. But now we're interested in this. Therefore, the summation of forces will be equal to mg sine theta minus the friction, which will be equal to max. So the summation of forces in the x-axis, or the resultant, is mg sine theta minus the frictional force, and we know that the frictional force is equal to mu k, the normal force. So in this case, the normal force and the y component of the weight, they are the same. Therefore, the normal force will just be equal to mg cos theta. Okay, the normal force will be equal to mg cos theta. We're just substituting here. We have friction being equal to mu k. Okay, we have friction being equal to mu k. The normal force is mg cos theta. Okay, so what is the normal force? So what is acceleration? Acceleration will be equal to, the force is mg sin theta minus friction, and friction we found that it's mu k mg cos theta, okay, over the mass. Okay, I hope we are together up to this point. Now, here we know mg common, so we have mg, we factorize, we have sin theta minus mu cos theta over m. Okay, the m and the m will cancel. We have acceleration being equal to g sin theta minus mu cos theta. So this is our acceleration. We have our acceleration. Okay, then now how do we find the distance, this distance here? Okay, so this distance will be equal to, so we are relating this distance to this height. Okay, so this distance will be equal to 1 over t a t squared. So we know that the x is h over sin theta, which will be equal to 1 over 2. Okay, we have our acceleration, so this is our acceleration here, which is g sin theta, okay, sin theta minus mu k cos theta times. So for the time, we know that our time it's 2 times the time it takes for it to fall freely. So 2, and we calculate the time it takes for it to fall freely, which is the square root of 2h over g. So we have 2h over g squared. Okay, now from this point, what do we do? It's just about calculation now. So we have, this implies that h over sin theta will be equal to 1 over 2 g sin theta minus mu k cos theta. Okay, so 2 squared, this is just the same as 2 squared, which is 4. The square root times square root, we have 2h over g. Okay, so we know this and this will cancel. Okay, this and this will cancel. So what are we remaining with? We have h over sin theta. Okay, we have h over sin theta is equal to 4 sin theta, okay, minus mu k cos theta, okay, h. So here we can multiply both sides by 1 over h. We get rid of the 1 over h. Okay, so to make it easier, I can multiply. I'll just multiply by 1 over 4h. Okay, so multiplying this one by 1 over 4h, the h and the h here will cancel. Okay, and this will cancel with this. We'll have 1 over 4 sin theta is equal to sin theta minus mu k cos theta. Okay, so we have this. So what does this mean? This implies that mu k cos theta is equal to sin theta minus 1 over 4 sin theta. Okay, So we know what theta is. So theta is 35 degrees. So we'll have mu k cos 35 is equal to sin 35 minus 1 over 4 sin 35. Okay? So you can just calculate. So what is cos 35? Cos 35 equal to 0.819 mu equal to sin 35 0.574 minus 1 divided by 4 sin 35, we have 0.436. Okay, so we divide this by 0.819, divide this by 0.819. Therefore, mu k is equal to, so what is 0.574 minus 0.436? So we have 0.138 divided by 0.819. Okay, so this implies that mu k is equal to, okay, so what is 0.138 divided by 0.819? Okay, we have 0.168. Okay, so this is how we find the coefficient of kinetic friction. Okay, thank you for watching this video, and don't forget to subscribe, okay, for more videos.